Yeah, as Jim mentioned, I've had the privilege of studying high-performing technology organizations. This is a journey I've been on for 19 years. And so back in 1999, I was the CTO and founder of a company called Tripwire in the Infosec and compliance space. And our goal was always to study these amazing organizations. We called them high performers that had the best project due date performance and development. They had the best operational stability, and they had the best posture, security, and compliance. And so the goal was, how did these amazing organizations make their good to great transformation? And the reason why we wanted to understand that was that we wanted to understand how other organizations could replicate those amazing outcomes. And by the way, that's when I met Allison Miller back in 2001. That's where I met so many people here. I'm just so delighted to be here today. But in that 19-year journey, there were many surprises. But the biggest surprise was how it took me into the middle of the DevOps movement, which I consider myself maybe one of the primary cheerleaders for. But I think it's a genuinely important solution to an even more significant business problem. And I think it touches everything about how we work with software. So in the next 40 minutes, what I want to share with you is what I've learned since 2013. So 2013 is when a book called The Phoenix Project came out, which is a novel about an organization that goes through all these problems, and really it's kind of positioned as a way to help describe the problems that DevOps is designed to solve. And so what I want to share with you are the top 5 learnings of what things I wish I had learned before the Phoenix Project came out. And when I say that DevOps is transformative, just to put this into perspective, I think that the last time that any industry has been disrupted to the extent that DevOps is disrupting our work today was probably manufacturing in the 1980s, when it was revolutionized through the application of the lean principles. So you take those same lean principles, apply it to the technology value stream, you end up with the same patterns and practices that allow organizations to do tens, hundreds, or even thousands of deployments per day while preserving world-class reliability, security, and stability. That's something that we didn't even think possible 10 years ago. So, and I said transformative, it is transformative to operations, as it is to developers, as it is to our business partners, but especially for information security, right? I think more than almost any functional role, information security, it changes how we do work. And when I say that I'm so delighted to be here, it's because that I had the privilege in 2012 of being in Austin, Texas, at the OWASP USA conference, where I got to watch Neil Matadel, Justin Collins, and Alex Smolin present one of the most astonishing presentations I've seen in my entire career, where they were talking about the things they were doing at Twitter to genuinely integrate information security into the entire dev and ops processes, right? In many ways, as a part of a consequence of the 2009 Federal Trade Commission consent decree. So I'm so pleased that all 3 are in the room. So here's number 1 surprise that I certainly wish I had learned before the Phoenix Project came out, was that the business value that DevOps creates is even higher than we thought. So this is based on work that I've been doing with a gentleman named Jez Humble. So he wrote the Continuous Delivery book. We wrote the DevOps Handbook together. Dr. Nicole Forsgren, and for many years with Puppet, we benchmarked over 26,000 organizations. And over the past 4 years, we've been able to identify what does high performance look like and what are the behaviors that cause high performance. So one dimension of performance is throughput and agility. In the 2017 report, so we've done this over 4 years in a row, we found that high performers are doing 46 times more frequent deployments. So think of deployments not only as just code, but to any changes in the environment. And more importantly, they can complete those changes 440 times more quickly. In other words, what is the cycle time as we go from code or changes put into version control? And version control is not just for developers, it is for operations and information security. Anyone who gets into production needs to go through version control, through testing, through deployment, so that customers are actually getting value. High performers can execute the cycle in 1 hour or less, whereas lower performers take orders of magnitude longer, right? Think weeks, months, or quarters. And it's not just about doing more work. We know that high performers get dramatically better outcomes when they deploy. We know that high performers, when they deploy, they're 1/5 as likely to have something bad happen, whether it's a service impairment, a 7-1 outage, a security breach, or a compliance failure. And bad things happen because Murphy's Law does exist. When bad things happen, high performers can repair those issues 100 times faster. In other words, the mean time to restore service is 100 times faster. So, in the early days of the research, this was shocking, right? Because it gave us decisive evidence that you can be faster and be more reliable at the same time. And in the early years, there was a lot of anxiety when we did the research because we were nervous that we wouldn't see it in that year's study. But now it's so routine. We know with moral certainty that the only way to get these kind of great reliability profiles is to do smaller deployments more frequently. And so over the last 2 years, we looked at other dimensions of quality. We know that high performers, because they're integrating information security objectives into everybody's daily work, they're spending 1/2 the amount of time remediating security issues, right? So it's twice. So we can see the effectiveness there. And because they're doing a better job controlling unplanned work, they're able to spend nearly 1/3 more time on planned work, right? So these are planned. This work tends to be more strategic, as opposed to the tactical, maybe even value-destroying work of firefighting. So as a population, we call that IT performance. 3 years ago, we looked at another area, which was organizational performance. And what we found was that high performers were also twice as likely to exceed profitability, market share, and productivity goals. And for years, people have been asking, what if we're a government agency? What if we are a military service or not-for-profit? And so in 2017, for the first time, we had a separate branch in the survey that said, if you're a not-for-profit, we took you down a different path. And what we found was the same multiple of performance. Not-for-profits were twice as likely to achieve organizational and mission goals, regardless of whether it was measured by quality, quantity, customer satisfaction, and so forth, right? So, I think the conclusion is pretty obvious, right, is that if mission achievement requires work from the technology value stream, the work that we do every day, DevOps helps with enablement of those things. Other markers of organizational performance include the fact that high performers, employees are twice as likely to recommend their organizations to their friends and colleagues as a great place to work. That's called the Employee Net Promoter Score. And there's a whole body of literature out there that says that that is highly correlated with revenue growth, profitability, and so forth. And there's this other thing that we found, which was that we found that high performers, for those publicly traded, they had 50% higher market cap growth over 3 years. And I just want to pause for a moment there to say this is in some ways an absurd finding, right? Because essentially what this is suggesting is that how a server admin, how a DBA, a developer, how they do their daily work could impact profitability and maybe even be visible in share price, which I think is kind of stretching believability. But I will be the first to admit that. But if we believe that strategic work is reliant upon the technology value stream, perhaps if those organizations can be 3 orders of magnitude faster than the competition, maybe that will create decisive winners and losers in the marketplace. And that I find to be incredibly believable. So I think it's just a really wonderful finding. There's another metric I want to share with you. And in the DevOps community, this is probably one of our favorite metrics, deploys per day, right? In fact, the seminal presentation about DevOps in 2009 by John Alspaugh at Flickr, who went on to Etsy, and his dev compatriot, Paul Hammond at Yahoo. They were shocked the world by saying they were doing 10 deploys a day every day. But what is interesting is, even more interesting, is this relentless increase in number of deployments per day, right? These days, Amazon, in 2015, Ken Exner said, at Amazon they're doing 130,000 production deployments a day, right? So the question is, what causes this relentless increase in number of deployments per day? And we started to hypothesize that deployments per day maybe is hiding an even more important metric, which is deploys per day per developer. And so we tested this. On the y-axis, you see deploys per day. And on the x-axis is the number of developers. And what we found was that as you increase the number of developers in low performers, deployments per day goes down. In medium performers, as you increase the number of developers, deploys per day remains constant. Whereas in the high performers, as you increase the number of developers, deployment per day goes up linearly. So this is a logarithmic scale, right? That is actually linear growth. And so what makes this so interesting is that so many of us were trained by Frederick Brooks in his book, The Mythical Man Month, right? He actually did explain so much of our common experience that in general, when you double the number of developers, or maybe more specifically, double the number of development teams, in general, you double the code integration effort, you double the testing effort, the securing effort, and you more than double the effort to get value to the customer, right? And I think we've all lived through that at one point in our career. But what this graph shows us is that under certain conditions, with the right architecture, with the right technical practices, and the right cultural norms, we can actually scale developer productivity linearly. And that's something you hear the high performers talk about, regardless of whether they are a developer in QA, ops, or information security. And I think this starts to suggest what the opposite of technical debt is. The opposite of technical debt is to what extent can we safely, quickly, reliably achieve all the goals, dreams, and aspirations of the organization that we serve. And maybe just to put this into perspective, one of my favorite statistics was Instagram. When they were acquired by Facebook for $1 billion, that was 10 engineers. Pokemon Go, the fastest property to 1 billion users, was 25 engineers. So I think kind of the goal of DevOps is like, how do you enable taking 25 engineers, put them into any modern business context, and have them do those kind of miraculous things? So surprise number one was definitely how good DevOps is for the achievement of business outcomes. Surprise number two is DevOps is as good for operations and security as it is for developers. In fact, oh my God, I love the fact that so many Facebook people here. So it's 2018, and still my favorite case study of how good is was the Facebook chat launch story that happened in 2008. Right? So some of you may roll your eyes because you're saying, it's 10 years old, right? How relevant can it be today? Some of you might be saying it's a chat server, right, that undergraduates write as part of their computer science curriculums. That's true too, but what you might not know is that chat is actually inherently an order n cubed algorithm. I think even to this day, they would consider chat to be the most ambitious technical undertaking ever done at Facebook still to this day. It took 1 year for them to do with the largest project team. And so what's interesting is like how they used that year. So imagine the chat team being constituted sometime in 2007. And very quickly, this team is starting to create code. And they're checking that code into a shared source code repo. Whatever was in the source code repo at 2 p.m. Pacific time would be silently migrated into the production environment without causing chaos and disruption. And what's interesting is they do it in the middle of the day. Right? Not at 4:59 p.m., not at midnight, right? They're doing it in the middle of the day, so if something goes wrong, they can roll back, or worst case, everyone's in the office to help if needed. So that's certainly interesting, right? As opposed to so many organizations today, they do deployments at midnight on Friday, and they have to work all weekend to get things running, right? So that customers don't notice if something goes wrong on 9 p.m. on Monday morning. So that's one technical practice. A second technical practice is the fact that they were testing in production for nearly a year. So for the vast majority of that year, whenever someone was logging into a Facebook property, there would be some JavaScript code that would run in the client and would send invisible test chat messages, to the servers, in the data center, right, invisible to customers. So why would they do that? It was so they could simulate production-like loads, right, well before the release. And so this is when they have the most amount of freedom to change things, right? If you find performance issues 11 months before the release of the product, right, you have 11 months to change things. You can even change architecture. Whereas if you find performance issues during the middle of the deployment, you have almost no degrees of freedom. So just to share with you why I think that's so interesting to me is that if you had told me 5 years ago that it would be okay for developers to test in production, I would have said, are you insane, right? It's like, I don't know what developers but I can promise you developers don't care about quality, right? If you've seen the things I've seen deployed in production, you would also conclude these things. And yet, I've changed my mind, is that I think to give developers the ability to test in production is an absolute game changer because it gives the fastest feedback of everything, right? Whether it's user visible, user invisible, non-functional requirements, or security. But let's go back to the notion of that daily deployment. Here's how important I think that is. I think the best person who's verbalized this is Nathan Shimmick. He said, as a lifelong ops practitioner, I know that we need these type of DevOps practices to make our work humane. In the course of my career, I've worked on every holiday, on my birthday, on my spouse's birthday, and even on the day my son was born. And so I think many of you might be like me, where you've had friends who have had to do this, or maybe even like me, where you've actually helped create these inhumane work systems that have forced people to live with this for maybe years. And I think we now know that there's a better way. So I think the common objection is that you can only do this for open source hippie companies like Facebook. And I think if that is a valid objection, but you should also know about this case study from CSG. So they're the largest bill printing company in the US. So I think even here in Hawaii, right, if you get a paper bill from Comcast, a Time Warner Cable, a Charter Communications, it comes from one of 2 bill printing plants in the US. They're publicly traded. And their focus of transformation was that bill printing application. In my mind, this is a pathological worst case of what anybody should be doing DevOps on. It runs on over 20 different technology stacks, including on the mainframe. The good parts are written in COBOL. The bad parts are written in assembler with vSAM databases. So vSAM databases are not even relational, right? They're column-oriented databases that you have to index into manually. It runs on over 136,000 Windows clients that run inside of their customers. So they doubled the release frequency from 2 times a year to 4 times a year. But that was predicated on the notion of doing a daily deployment. So that means every day they had a team that spanned dev, QA operations. They would deploy into a UAT environment every day in a UAT environment that was almost architecturally identical to the production environment. So what happened? 1 year later, the incident count when they did a production release went down 90%. The mean time to repair when things went wrong went down by 98%. For me, the most interesting telling indicator is what happened to code deployment lead time. 1 year prior, whenever they did a release, imagine it went from 14 days. So 14 days of what? Imagine a release team trapped in a war room, panicking because things are going wrong, customers complaining, executives coming in saying, are we done yet? To which they would have to respond, no, we're not done yet. We have 14 days more to go, right? 1 year later, the release was technically complete at 1 p.m., right? The Xboxes come out because they're just waiting for formal customer acceptance. So it's great for dev, ops, great for the customers because they can get value in half the time. And my claim is if you can do it for something that looks like this, my claim is that you can do this for anything, that these principles transcend the technology stack that it runs on. So obviously great for operations. So let's go to the reciprocal, some technical practices that affect developers. This is still one of my favorite quotes from Patrick Lightbody. In 2011, he said, we found that when we woke up our developers at 2 a.m., defects got fixed faster than ever. Werner Vogel said it even more succinctly, if you help build it, you must help run it. And so I am aware that jackasses like me, showing off jackass slides like this, is probably mobilizing an entire generation of developers to hate DevOps, right? They will now sabotage any hint of a DevOps initiative because I think what they will say is, we did not become developers to wear a pager, right? Pagers are for ops people, right? The whole reason why ops people became ops people was because, they like pagers, right? And so there's an internal consistency to that logic, but I think the more telling narrative comes from Tim Tischler. For many years, he ran the DevOps initiative at Nike, and he said, as a career-long developer myself, the most satisfying point in my career was when I got to write the code, when I got to test it myself, when I got to push it into production myself, when I could see the happy faces of my customers when it worked, and when I could see their angry shaking fists when it didn't work, and when I could fix it myself. And which I thought was astonishing, and just in and of itself. And he then went on to relate to me that he said, over the past 10 years, our ability to self-test, self-deploy, and God forbid, self-fix has been diminished over time, thanks to things like ITIL, security and compliance, right? And by the way, I came from those communities, right? Thanks to jackasses like me, he said, it's taken almost all the joy out of development work. And what is so interesting and paradoxical to me is that these type of practices of putting developers on page rotation actually allow us to bring joy back to developers, increase their productivity, and get far better reliability outcomes and security outcomes for them. By the way, how am I doing here so far? Am I being too cavalier about this claim? Thumbs up? Is this interesting? And by the way, just to show you that I'm not that gullible, at least initially, in the first year of the State of DevOps Report, Jez Humble and we had a bet. We asked who would have better deployment outcomes, developers or ops people, right? And Jez being a dev lover, right, he said it would be developers, right, because they are closest to the work, they understand how the pieces fit together, right? They would have better deployment outcomes. And I argued that ops would, for exactly those same reasons. So we split the population into those where devs deployed versus those where ops deployed, compared the change success rates. And the surprising answer was that they were the same. Right? They're statistically identical. It actually didn't matter who deployed, who pushed the button. What mattered was the presence of version control, automated testing, telemetry, the sense of a win-win relationship between dev and ops, right? Those are what mattered. And if those were present, they had better outcomes. It actually didn't matter who pushed the button, right? So, and thus I was convinced. And it's not just me. There's a growing body of people in the DevOps community, not DevOps in the security. They're saying that security is just as important. Topo Pal, he's the first technical fellow at Capital One, They call it DevOps Sec there, right? And what I love about this is that this, in my mind, is the ideal embodiment of how we integrate security objectives into everyone's daily work. So we have all the preventive controls living in a shared source code repository. So anyone can pull from those and inherit the best known understanding of how to solve a problem, whether it's how to do authentication or do password policies or configuration settings. Alongside automated testing, they're doing things like static code analysis so we can find vulnerabilities before it gets into production. Alongside production monitoring, we're running dynamic testing so we can find out about vulnerabilities before attackers do. And the responsibility is held by developers. It's not security solely responsible for it. It's everybody's job. And I think that's what's so exciting to me about DevOps. It's not just dev versus ops versus security. Increasingly it's dev and ops and security all working together as fellow engineers trying to achieve a common objective. So surprise number one was the business value that DevOps creates. Surprise number two was just how good it is for dev and ops and security. Surprise number three is this. There's a metric that looks very tactical. It looks laughably tactical, and yet I now believe it is the most strategic measure of any technology organization, and it's code deployment lead time. So I mentioned in the DevOps community, we love this metric, deploys per day. But in the lean community, that is obviously not their favorite metric. Their favorite metric is lead time. So they would, in fact, there's this deeply held belief in the manufacturing community in lean that goes back almost 60 years that says lead time is the most accurate predictor of internal quality, external customer satisfaction, and even employee happiness. And we found in our work spanning 26,000 respondents that lead time has this sort of magical predictive capabilities in our work as well. And so in manufacturing, they would probably measure lead time as we start the clock when the customer orders, and we stop the clock when the customer receives what they ordered. Or maybe a plant manager would zoom in a little bit and say, we start the clock when we have raw materials at one end of the plant, and we stop the clock when those finished goods are on the way to the customer. So in our research, we chose to define lead time as it starts when a change is put into version control, as it goes through testing, as it goes through deployment, and so that customers are actually getting value. And I think that might beg the question, why do we start the lead time clock at version control, right? Why don't we start it earlier when dev accepts work to go into implementation, or maybe when an idea is first conceived, right? And those are both valid places to start any sort of lead time measurement. But the point at which changes are put into version control, in our mind, represents a very special place because they divide the technology value stream into two qualitatively different parts of work. So everything to the left of code commit is design and development. So the nature of design and development work is that often we're doing work for the first time, maybe never again to be repeated, right? So think about Facebook chat, right? It took 1 year to do, right? And so the lead times are very variable, right? Because we never get a chance to practice. And I think that's just the nature of design and development work. However, everything to the right of changes being put into version control is testing and operations. I would put security in there as well, or a good chunk of security as well, because we want testing and deployment and a lot of information security to have the exact opposite characteristics. We want them to happen not once a year. We want them to happen all the time. We want it to happen quickly, repeatedly, ideally completely mechanistically, right? The same time, every time. And so code deployment lead time simultaneously predicts the effectiveness of testing and operations, but it also predicts how quickly can we give developers feedback on their work. So if I'm a developer and I make a mistake, or I introduce a vulnerability and I check it into version control, if the first time when I could detect that error is 9 months later during integration testing, or when the security team sends me a PDF file, right, the link between cause and effect has almost vanished, right? In fact, arguably, if someone broke the code, right, it's not me, right? It's probably the 99 other developers who are working on that piece of functionality, right? And so the time to detect, time to fix are exponentially harder. What we want is, in the ideal, is that the instant I introduce that change into version control, that should kick off automated testing. And so I should detect that error within minutes, worst case hours, right? And so that allows me to not only find my error, but it also prevents me from making that same mistake, every day for the next year. And the same thing, I think, holds absolutely for security as well. So code deployment lead time simultaneously predicts effectiveness of testing and operations, and it predicts how quickly can we give feedback to developers on their work. So not only can they learn, right, from mistakes, but also how quickly can they learn from customers. So how am I doing here so far? Is this interesting? Yeah. So it looks tactical, and yet I believe it is the most important measure of any technology organization. And it turns out there's actually one question you can ask that predicts all the metrics I've shared with startling accuracy. It predicts the presence of all the technical practices, cultural norms, and architecture, and you can predict all of that with one question. On a scale of 1 to 7, to what degree do I fear doing deployments? Right? And it's like a line. You plot that on the x-axis, you put any other measurement on the y-axis, and if it's 1 is, we have no fear at all, we do them all the time. 7 is we have existential fear of doing deployments, and that's why we do them, in our ideal, never, right? And so there's a surprising amount of power just in asking that one question that spans dev, QA, operations, and Infosec. So surprise number 1 was the business value that DevOps creates. Surprise number 2, how good it is for dev, ops, and security. Surprise number 3 is this importance of code deployment lead time. Surprise number 4 is the surprising implications of Conway's Law on everything that we talked about. And so it's my observation that around 2012, any DevOps meetup, conference, someone would be talking about Conway's Law. And I quickly learned that what Conway's Law is. The most popular paraphrase of it came from Eric S. Raymond, who wrote the book The Cathedral and the Bazaar about the open source movement. He said if you get if you get 4 groups working on a compiler, you will get a 4-pass compiler. This is summarizes the work that Dr. Melvin Conway did in 1968, where he showed that there is a stunning link between how teams are divided and the outputs they create. So I could, certainly by the 4th time I had heard this, I could repeat that back to you. But what I could not do is actually tell you how should that inform how we should design or execute our daily work. Until I read the story about the birth and death of Etsy Sprouter. I would love to see if this resonates with you, Mike, from your Etsy experience. But essentially, this is a story about how teams work together to create value. So back in the bad old days of Etsy, in 2008, one of the big problems they looked at, and by the way, in 2008, this was like the bad old days of Etsy, right? This is a day when most people said, if we have to go through another Christmas holiday season like this, we're out of here, right? But even in 2008, they saw this big problem where that in order to ship any sort of functionality to the user, 2 teams had to work together. The devs would work in the front end, and that would be in PHP, where the DBAs would have to work on the back end, and then that was inside of the stored procedures inside of Postgres. And so what they observed was that when you have 2 teams that have to work together, they have to communicate, coordinate, prioritize, sometimes conflict, deconflict, and marshal. And so their goal was to see if they could make these teams be able to work more independently, right? And so that's why they created something called Sprouter. It's short for Stored Procedure Router. And the idea was that the devs and the DBAs could work independently, and they would meet in the middle inside of Sprouter. And as I think it was Ian Malpass said, he said this required a degree of synchronization and coordination that was rarely achieved, to the degree that almost every deployment became a mini outage, right? And so what's so interesting to me about this is that Conway's Law would predict this, right? Is that we went from 2 teams having to work together to 3 teams, right? The amount of communication and coordination goes up, deployment lead times go up, right? And deployment success outcomes go down. So as part of the great rebirth of engineering greatness at Etsy, one of their goals was to kill Sprouter. What they wanted to do was to enable development teams to fully and independently be able to do everything they need to do in the front end. So they used an object relational model so that they could make all the changes inside of PHP. Right? And what they found was that in every place in the Etsy property, way they killed Sprouter, suddenly code deployment lead times went way down and deployment success went way up. Right? And again, Conway's Law would suggest this, right? Because as we went from 3 teams down to 1 team, right? With 1 team, you don't have to communicate and coordinate with anybody. That team is totally self-sufficient and able to get into production, right? And so the lesson to me here is that it's not enough to move boxes around on an org chart. we must also have an architecture that is congruent to that, that enables these teams to work independently. And so in that Etsy example, the numbers are very small, right? The worst case is 3 teams, right? In most modern organizations, it's not 3 teams that have to work together. It's probably like 50 teams, right? It's the DBAs, it's the network engineers, it's the firewall engineers, it's the middleware people, and God forbid, security, change approval, and all these people, right? So it doesn't take much to go wrong, right? For us to have lead times measured in weeks, months, or quarters. And this represents an architectural problem. So one of the big learnings for us in the State of DevOps Report 2017 was the significance of architecture. We found that these things were actually the top predictors of performance. To what degree can teams make large-scale changes to their parts of the system without requiring permission from anybody else? To what degree can they complete their work without a lot of fine-grained communication and coordination with other people outside their team? Can they deploy and release on demand? Can they do their testing on demand without use of scarce integration test environments, of which there are never enough, right? If all those things are true, then of course they'll be able to do deployments during normal business hours with negligible downtime. So the reason why I think this is so surprising to me, right, is that in my day at Tripwire for 13 years, right, we were always trained that it was safe to ignore architects, especially chief architects, because they would live in their ivory tower, right? They would come out only once a year, publish one PowerPoint slide, send it to everybody, and they would go back into the ivory tower, right, never to be seen again, right? And I think that's just another way of saying they didn't impact how people do their daily work, right? And I think a lot of security people could fit into this category. And yet we now know that actually architecture is one of the most dominant ways that predicts IT performance and organizational performance. And so I think this is why this shows why we love platforms so much. In the ideal, these development teams should be able to do almost everything self-service and on-demand. They don't need a ticket, they don't need to wait, and that actually creates conditions where they get immediacy and fast feedback. They get focus and flow and even joy, right? Just as was mentioned by the gentleman from Nike. So everything from monitoring, deployment, environment creation, security scans, deployment, all those things, we can do those things safely now. So there's one other story I want to share with you. And in fact, this was one of the most startling, and the words existential despair comes to mind. One of my mentors, her name is Elizabeth Hendrickson. She's pioneered so much of the automated testing practices over the last 15 years. She told me about how she was a part of something called the Los Altos Workshop for Software Testing. And so this was an amazing group that met for over a decade. They had 60 workshops. This was the best software QA people in the game. No consultants allowed. These were people who actually owned line responsibility for QA for some of the most important properties on the planet. And she said, we did many exercises, but there was one that she remembers very, very well, which was they asked, what was the dev to QA ratio for your best project and your worst project? And there was a surprising amount of unanimity in the answers. For people's the people's worst projects had often the highest dev QA ratios, right? Sometimes approaching 1-1. But what was even more stunning was people said, for my best project, the answer that kept on coming up over and over again was, we had no testers, right? So this is prone to misinterpretation. But in my mind, this is so profound, because essentially what she said is, the learning was, we found that when we had no testers, everybody knew that there was no one else who was going to find their problems for them, right? It was our job. And I think what we can extrapolate from this is that we have the best security when there is no external security group who's going to find our security problems for us. Right? And I think it means that our expertise as security professionals is going to be putting that into platforms, right? Or embedding our expertise into teams. Right? And by doing that, we help developers fully own both operational responsibilities and security responsibilities. So, surprise number 1, the business value that these patterns create. Surprise number 2, it's great for dev, ops, and security. And by the way, I think this actually lends to more satisfaction for security professionals. Right? We get to be coaches and consultants, not the people with the badges flashing them at people, trying to get them to do something that they don't want to do. Surprise number 3 was Conways Law. Surprise number 3 was code development lead time. Surprise number 4 is Conways Law. Surprise number 5 is this, is that I think academics 10 years from now, when they look back, they will say, there was something genuinely transformative that happened around this time. Cloud is going to be a part of it, but I think Agile is certainly going to be a part of it. But I think the dominant narrative will be DevOps, but I think they'll also say that DevOps was part of something much, much larger. And I think they're going to say it was a part of a larger category. They'll probably call it dynamic learning organizations. And the most famous example of a dynamic learning organization is Toyota and its family of suppliers. My favorite authority on this is Dr. Steven Spear. He wrote probably the most famous Harvard Business Review report of all time called Decoding the DNA of the Toyota Production System in 1999. This was actually based on his PhD dissertation that he did at the Harvard Business School, where as part of that, he actually worked on the assembly line of a Tier 1 Toyota supplier for 6 months. In fact, what was interesting is that the Toyota executives let him do this, but he said it was only under one condition. He must first work at an American Big 3 auto plant for 30 days, essentially saying, you're going to see many interesting things here, but you won't appreciate them until you live in a more traditional work system. So over the years, he's extended his work beyond just manufacturing that's highly repetitive, highly mechanistic, to things that are wildly different, things like engine design at Pratt & Whitney, to the safety culture at Alcoa, to the design and operations of all nuclear reactors in the U.S. Navy seagoing fleet. And he said that designing perfectly safe systems is likely beyond our abilities. And I'll just pause for a moment and say, I don't think there's any work more dangerous than the work that we do. Because one of the marks of dangerous, unsafe systems is that small changes can have global catastrophic impact. Right? So think about the Hawaii civil defense emergency. Think about the Equifax breach. Think about the shutdown of British Airways for 3 days. That stranded 70,000 passengers in the UK for 3 days. Those are all marks of a very unsafe systems. But even in our work, safe systems are close to achievable when 4 conditions are met. You have to see problems as they occur, right? So, the idea is that we want to see as quickly as possible where work as designed is not actually work in real life, right? So that's like assertion statements in code, which is actually kind of an interesting thing. We're actually saying it's actually better to kill the program than to let it operate when we're starting to drift from, known assertions. That's where we have telemetry for everything in production. And Etsy is probably one of the most famous examples of this. It's not enough to see problems as they occur. We also have to swarm them, meaning that we have to solve problems and potentially even escalate to everybody in the organization so that we can find and fix problems quickly. We have to spread new knowledge throughout the organization, and we have to think about leadership in a wholly different way. So actually, I'm going to go straight to number 3, because in my mind, this is actually probably the biggest moment in the development of the DevOps Handbook, because when I took his workshop at MIT, when he talked about Capability 3, it revealed that we had missed a bunch of stuff. So Capability number 3 says there must be some mechanism that allows for local discoveries to be elevated and translated into global greatness. And I think we see this a lot in our work, but for me it was very startling. I think one of the best examples is a single shared source code repository. Right? The most famous example of this is Google. Almost every of the 45,000 engineers at Google, with the exception of Android and a couple other teams, they work out of one source code repo, one giant continuous integration system. Only one version of each library allowed. Right? Every library has an owner, and they are responsible for working on version N and migrating on everybody to version N+1. Contrast that to a friend of mine. He said, at a large bank, we have 93 versions of the Java struts, the struts library, right? Arguably, we are running every version except for the one version we should be running, right? Versus at Google, they're running one, and it means that we can put all our expertise into code. Anyone that pulls from that repo is automatically inheriting the best known understanding of how we solve problems. Blameless postmortem is another one of these, that we must make it safe for people to talk about problems. As Bethany Macri at Etsy said, prevention requires honesty, and honesty requires the absence of fear. And what it does is that it enables engineering competitiveness so that we can actually brag about who has the better war stories to tell. And all of these things ultimately create safer systems. If we don't have enough outages, we stop having them just on outages, customer impacting outages, we have them on team impacting outages. Of the 7 safeguards we put into place to prevent an outage, 6 of them failed. Let's do a postmortem on that. Etsy was famous for doing postmortems even after a flawless retail season, holiday season, just so they can learn from it, right? And that represents ever-increasing tightening tolerance, and that creates greatness. Sometimes there aren't enough outages. We create outages, like the famous Chaos Monkey stories. So all learning days, technology conferences like this, open source. Open source is interesting because now we're not leveraging the best minds within the walls of the organization. Now we're leveraging the best minds of everybody in the entire technology community. So all of these, I think, are great, and it says that our goal as security leaders is not to create buoys and we trap everyone inside the buoys. It's really to create boundaries that says, hey, you are closest to your customer and the business objectives. If you need to stray outside the buoys, right, you can, right? But here are the principles that you must adhere to. And maybe that's going to be the next breakthrough that we will then empower the rest of the organizations to use. So the last thing I want to share with you has been my area of research for the last 4 years, which is studying not DevOps in the unicorns. And by unicorns, I mean the Google, the FANGs, the Facebook, Amazons, Netflix, Googles, and so forth. That's interesting, but not as interesting as DevOps in large, complex organizations, say the horses. And so my primary mechanism for learning about this has been running a conference called the DevOps Enterprise Summit. And our goal was to understand how is DevOps being used in large, complex organizations. And without a doubt, you should be confident seeing that almost every large brand and every industry vertical is using the same practices that the unicorns and FANGs are and using it to drive incredible innovation in their organizations as well. I'll give you instructions on how to get my slides, but there's one thing I want to share with you that has been very meaningful to me, which is the notion of the role of the leader. One of the things that we tested in the 2017 study was the role of leadership. And we specifically used something called the transformational leadership model. And what we found was that leadership matters. We tested the presence of 15 things in 5 categories. To what degree does a leader understand the vision of the organization? To what extent can they get ahead of that to not only contribute and be relevant, but to help with the achievement of some of the most important things for the organization? Intellectual stimulation. To what extent does leadership challenge status quo, challenge basic assumptions of how we do work? Just because we did it the same way for the last 20 years doesn't mean that it's the way we should be doing things today. Inspirational communication. To what degree can the leader generate a sense of excitement about the work that they're doing? Maybe having to overcome deep, profound fears of what this does to our career, to our professions, to our functional silo, and create coalitions to help overpower very powerful incumbent systems. Supportive leadership and personal recognition. Those are called often associated with servant leadership that Agile popularized. And what we found was that leadership does matter. The punchline is that teams with the least amount of reported transformational leadership behaviors were only one half as likely to be high performers. So it's possible, but a lot less likely to succeed. And it takes more than just leaders, right? It takes great teams with great technical practices, with great architecture and cultural norms. In other words, leaders just hanging out with leaders without teams is just people giving PowerPoint slides to each other, right? Here's the evidence. We took the teams with the top 10% of reported transformational leadership behaviors, took their performance, compared it against the median, and they were actually worse, right? So it takes more than just transformation leaders. It takes everything that we've discussed in this presentation. So why do I think this is important? It's because DevOps is now, I think, relevant to every organization. It doesn't matter what industry we're in, whether the size of the organization, whether we're profit or not-for-profit. The presence of these practices helps us achieve goals. It leads to more satisfied teammates, and I think it leads to where all the exciting work will be happening in information security. So I'm so delighted to be here. I'll be here for the entirety of these 2 days. And if you want a copy of these slides, if you want a whole bunch of stuff, including some work that we've done showing how we can prove to compliance and regulators how DevOps can help achieve security and compliance objectives, all you have to do is send an email to realgenekim@sendyourslides.com, subject line DevOps, and you'll get an automated response with all the stuff. So with that, thank you so much, and I'll catch you later today. Thank you.